Hello, innovators, and welcome back to Idea Mechanics. Our whole mission here is to show you that innovation isn't some random spark of genius. Nope, it's a skill, a system that you can actually master. Today, our lead expert, the Navigator, is going to guide us through a really powerful tool from the TRIZ methodology. We are diving deep into Principle 33, Homogeneity.
Okay, so in manufacturing, you see this all the time. So many teams get stuck in what we call the trial and error trap. They're trying to force different, often incompatible materials to work together. And what happens? They just accept friction, corrosion, and wear and tear as, the cost of doing business. But this just leads to failures that honestly could have been avoided from the start. So as our lead innovation catalyst, the Navigator, would ask, why? Why do we keep doing this? Why force materials to basically fight each other when there's a much smarter, more structured way to solve the problem? Now that's the big question we're tackling today. If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next.
All right, let's get into it. This is where we introduce the new way of thinking. It's a huge shift, moving away from those messy material mismatches and towards something we call engineered unification. It's a game changer.
This comparison here says it all, doesn't it? On one side, you've got the chaos of guesswork and constant problems. On the other, control. Our Navigator is pointing it out for us. This is the path from random chance to deliberate, intelligent design.
So, what's guiding this shift? It's TRIZ Principle 33, Homogeneity. And the rule is so simple, but so powerful. Make things that interact with each other from the same material, or at least materials with identical properties. That's it. This is how you engineer reliability right from the start, not just hope for it later.
Okay, enough theory. Let's get practical and see how this works in the real world. Our first case study shows how this principle guarantees performance, especially when things get really, really tough.
So picture this. You're trying to cut something incredibly hard, maybe some industrial-grade ceramic or glass. The old way, the wear and tear trap, is to use a cutting tool that's softer than the material. It's this constant, expensive gamble that always ends the same way. Dull blades, ruined products, and just constant replacement.
And here it is, the inventive solution. The Navigator is showing us the core logic right here. Instead of fighting with different materials, we aim for total compatibility. In a case this extreme, you use a tool made of a material, diamond, that has far superior properties. It's about absolute material matching. You literally eliminate the problem of wear from the entire equation.
So what's the big win here? The crucial point is that we have completely engineered the problem of wear and tear out of the system. Gone. The result? Perfect reliability, clean cuts every single time, and a tool that actually lasts. That's performance by design, not by chance.
Okay, so that was a mechanical problem. Now let's see how this same thinking applies to a completely different field. Our next case study tackles a really dangerous chemical challenge.
The contradiction here is pretty serious. You have to contain a corrosive chemical, right? But the container you put it in is at risk of being eaten away by that same chemical. A material mismatch in this situation isn't just inefficient, it can be totally disastrous, leading to leaks or contaminating the entire product. And the solution? Oh, it's just beautifully elegant. You just apply chemical homogeneity. You make the container from the exact same type of material as the chemical it's holding. For instance, if you have a corrosive liquid that's plastic-based, you store it in a container made from that very same plastic. By doing this, you completely eliminate any possibility of a chemical reaction. It's a foolproof system. It guarantees the product stays pure and everyone stays safe. This just proves it again. Reliability isn't an accident. It's an architectural skill that comes from deliberate design.
All right, one last proof point to really drive this home. Let's have a look at how the homogeneity principle can seriously boost efficiency in something like electric motors.
In a typical electric motor, you've got copper windings interacting with an iron core. But here's the thing. These materials have very different properties. That mismatch creates what we call an inefficiency barrier. Energy gets lost as heat, and the motor's overall performance just suffers.
So what's the engineered solution? Well, our Navigator is showing us exactly how to unify these components. For high-frequency jobs, engineers apply homogeneity by making both the windings and the core from the exact same material, like ferrite.
The takeaway is a beautifully efficient system.
I mean, by unifying the materials, you create this seamless synergy. Energy losses drop, and the motor becomes way more efficient and reliable. It's just another huge win for intelligent, systematic design.
Okay, let's bring all this together. What does this really mean for you, as an innovator in whatever you do?
The core message today is this: true reliability is not something you just hope for, it's something you build. It is an architectural skill. And by shifting your mindset away from fighting friction and towards engineering unification, you can systematically design systems that are better, simpler, and way more reliable.
And that leaves us with a final challenge for you. I want you to look around, at your work, at the products you use every single day. What system out there is way too complicated just because of mismatched parts? And now, how could you apply this principle of homogeneity to make it beautifully, effectively simple? That's your homework, something to think about.